Okay, everybody, back for the third and final installment on this problem. We're looking at the silver nitrate problem with barium chloride. The last step here is to actually figure out your percent yield, which is what I'll do here. So we've already figured out the limiting reactant. That's going to be your step one. Okay, step two is to find the mass of the silver chloride, okay, which is over here. Okay, that's what I did, and I solved that in the last video. Okay, and the last part is to now calculate my percent yield. So let's go ahead and get rid of this calculation here. And let's take a look at how I will find the percent yield. Remember, percent yield is going to be, essentially you're looking at is your comparing the actual measurement that you got in the laboratory. So this is from the lab. And I know this sounds confusing because the experimental was experimental and then there was an actual in our percent error calculation, and this is why things get very confusing for students. But what we mean actual here is this is the actual amount obtained in the lab. So this is from experiment. So this is what is going to be given in these problems, because obviously you're not doing the experiment part. So we're going to actually find this number truly being measured as 4.00. The theoretical is based on your calculations and what you think you should get, and that mathematical calculations are never a reality because it's mathematics and it's not. It can be based on your calculations, based on data. But when we do this calculation here, if I have this and this, I am theoretically calculating how much silver chloride I get. So that mass of silver chloride, which I inadvertently erased and can't remember what it is offhand. Which I can easily calculate though. I can quickly take this number here and find the mass by using molar mass of silver chloride, which I'll do real quick. So 0.035 times 143.35. That's right, it was 5 point something. So the mass here is 5.02. Okay, this number here is going to be what's called your theoretical amount, because in theory, this is how much you should have gotten. Theoretical. Okay, so that's your theoretical amount of silver chloride. This is the actual amount they obtained. Obviously, they didn't get enough, okay, in the lab, and that's typically what happens. So what we want to do is calculate a percent yield for this experiment. How close did they get to the actual amount? So to do that, what we're going to do is we're going to take this percent yield, and we do the essentially we're going to take the theoretical amount that we have, and that's going to go in the bottom, and we compare that to our actual. So it's actual over theoretical. I drew a blank there and I said to kind of derive it in my head, so I apologize. But this way I work. So anyway, percent yield, actual on the top, theoretical on the bottom. Theoretical is going to be the mark you're trying to get. Actual is how close you got to that number. So percent yield will be my number of 4.00 grams over 5.02 grams. And I'm going to go ahead and multiply that by 100. And that will give me my percent yield. Okay, so 4 divided by 5.02, multiply that by 100. And what we find is that we only have 79.7% yield. Okay, what that means is that I only got 79.9 or 79.7% of that number. All right, I didn't get. It's not a good lab. Theoretical percent yield is the opposite of percent error. So percent error measures how close you are to zero. The percent yield, you're trying to shoot for 100%. Right? Percent error, you want 0. Percent yield, you'd like 100%. So, not very efficient. So as a as a chemical engineer, what you would probably try to do is sit down and say, okay, why is our process not getting us the yield that we want? We want to try to get this up to close to 100% if we can. Usually 90% is somewhat acceptable. So depending on the industry and you're working in, you would have to find a method or a way to get that percent yield to come out higher. Why did we only get 4 grams when we should get close to 5 grams? Now, it's not likely, but you can get a percent yield to go over 100. If you get a percent yield that goes over 100, that doesn't mean you broke the laws of chemistry, because you can't go beyond what you theoretically can get. What that means is you probably have a contaminant in there. You have something extra in there that's making the mass of this go higher than what it should be. Okay, so if you're only supposed to get 5 and you end up with 5.5 something, well, that 0.5 something is probably junk you don't want in there, and you probably have to go back and do the lab again. So hopefully that helps you with understanding percent yield. Go back and watch the other 2 videos if you need to. Remember, limiting reactant is important. You got to find that first. Once you find your limiting reactant, you're going to use that to figure out how much of the material you're looking for, in this case the silver chloride. And once you get that, you then plug it into the percent yield equation. Okay, and again, if you needed a massive excess, this table makes it nice and neat and easy to find any other question. So sometimes with a problem like this, obviously you didn't need to worry about this section, you didn't have to worry about this section, but I threw them in there just to kind of help you, if you know, for other problems that you're going to see that get more challenging. So I think that's pretty much it. Don't forget, if you have 2 reactants and I give you the material for both, then you have to find limiting reactant. So let's say I didn't give you this 4 point, let's say this wasn't here. A lot of times they would say that that's excess. Then right away, that's your limiting reactant. So if they give you just one of the reactants, it's assumed that the other reactant is excess. You just have to go right to plugging into the equations. So anyway, please ask some questions in class, and I'll see you guys soon.